Good morning, my dear students. Our chapter number 4 is going on, which is electrical capacitance. In this chapter, we were studied about a capacitor, principle of capacitor, and a parallel plate capacitor. And we determined capacitance of a parallel plate capacitor is C is equals to A epsilon naught upon D. A epsilon naught upon D. Here D is equal to the distance between the plates of a capacitor and A area of a capacitor. And epsilon naught is the permittivity of a vacuum. From this equation, we can define dependency of capacitance on the factors like area and medium and distance between two plates. Okay. Today we discuss about capacitance, dependency of capacitance on the medium between the plates. Okay, so our first topic, effect of dielectric medium field between the plates of a capacitor. It means if we feel dielectric medium between the plates, then what are the change in capacitance of a capacitor? Okay, so we have a capacitor. Suppose we have a capacitor. This is a capacitor. This first plate is attached with plus Q charge. Then plus Q charge is spread out on this plate, and this plate is attached with ground. Then due to induction, here negative charge will be induced of same magnitude of this charge. So here surface charge density is plus sigma and here minus sigma. Then a electric field is produced and direction of electric field is positive to negative. This is electric field. Now we feel dielectric medium between these plates. Then the atoms of this medium, it means substance, become polarized like this. This negative, positive, negative, positive. This type polarized. Okay? And here these atoms align to the direction of a electric field like this. Okay, in this condition, here a induced surface charge density is produced. We can say that positive charge density plus sigma p induced near to the negative charge surface charge density minus sigma p is induced near to this positive plate, and induced positive surface charge density plus sigma p is induced near to this negative plate. Okay, so here a new induced electric field will be produced, and this is represented by EP. And direction of induced electric field is to opposite to the electric field which was already present between these plates. Okay, so in this condition, this original electric field between the plates of capacitor, E is equals to sigma upon epsilon naught. This electric field between these plates, in this condition, Here we assume vacuum medium filled between the plates. Now we fill dielectric medium between these plates, then induced electric field. Induced electric field in dielectric medium. Dielectric medium, which is EP, is equals to, here sigma is replaced by sigma p. Here sigma p is the induced surface charge density, sigma p upon epsilon naught. Okay. Here we see that this induced electric field, direction of this field is opposite to this original electric field. Then resultant electric field in dielectric medium, which is denoted by E1, is equals to vector sum of both electric fields. It means E plus EP, but here direction of EP is opposite to this E, then E minus EP. Put the value of E and EP, then E1 is equals to sigma upon epsilon naught minus sigma p upon epsilon naught. Here we take LCM, then E1 is equals to sigma minus sigma p upon epsilon naught. This equation number 1. This equation is written by this process, but by the definition of a dielectric constant epsilon r, we know that E1 is equals to, from the definition, E1 is equals to E upon epsilon r. Means resultant electric field is equal to the 1 upon epsilon r times of a electric field, is equals to, put the value of E, then sigma upon epsilon naught epsilon r. This equation number 2. Equation 1 is represent the resultant electric field, and equation 2 is also represent the resultant electric field. So from equation 1 and 2, E1 is equals to sigma minus sigma p upon epsilon naught is equals to sigma upon epsilon naught epsilon r. This equation number 3. From this equation we can say that, because we know that epsilon r for any medium greater than 1. So from this equation E1 is less than E. From this equation or this equation, E1 less than E, because of epsilon r always greater than 1. So from this equation we can say that electric field in a dielectric substance is less than the electric field which was already present between the plate of capacitor. And due to this we can say potential difference also decreases. So from this equation C is equals to Q upon V. At constant charge, amount of charge, if we decrease in a potential difference, then capacitance will be increased. So we can say that due to this, here electric potential difference becomes decreases, then capacitance of the capacitor will be increases. Okay. So we can say if we fill dielectric medium between the plates of capacitor, then capacitance of that capacitor will be increased. Okay students, now again from this equation 3, sigma minus sigma p, epsilon naught to epsilon naught cancel out, is equals to sigma upon epsilon r. So induced surface charge density sigma p is equals to sigma minus sigma upon epsilon r. So sigma p is equals to sigma 1 minus 1 upon epsilon r. This is induced surface charge density. We know that polarization vector P is directly proportional to electric field, and we remove proportional constant, then we write a proportional constant chi e and multiply E1. E1 is the resultant electric field, and here chi E is the electrical susceptibility. Okay, and here we can say the magnitude of a polarization vector is equal to the induced surface charge density. It means sigma p. From these equations we can write chi e E1 is equals to sigma p. Put the value of E1 and sigma p, then we get chi e value of E1, this sigma upon epsilon naught epsilon r is equals to sigma p sigma 1 minus 1 upon epsilon r. Epsilon to epsilon cancel out, and we take LCM, then chi e is equals to epsilon naught epsilon r minus 1 upon epsilon r to epsilon r cancel out, then we get chi e is equals to epsilon naught epsilon r minus 1. This is the relation between electrical susceptibility and dielectric constant epsilon r. Okay, students, now we feel dielectric substance in a capacitor completely. Okay, so our next topic, capacitance of a parallel plate capacitor if dielectric constant is completely filled in the plates, in between the plates of a capacitor. Okay, due to this, what the effect we get about electrical capacitance? So we assume a capacitor and area of plates of capacitor is capital A, and this plate is attached with plus Q charge and this attached with ground. Then due to induction, negative charge will be induced. Distance between these plates is d, and we feel a dielectric constant of dielectric medium of dielectric constant epsilon r is completely filled in this capacitor. Then resultant electric field between the plates E is equals to sigma upon epsilon. Here epsilon is the permittivity of medium. Since epsilon r is equals to epsilon upon epsilon naught, so epsilon is equals to epsilon naught epsilon r. Put the value of epsilon in this equation, then E is equals to sigma upon epsilon naught epsilon r. And we know that sigma is equals to surface charge density equals to charge upon area. So E is equals to Q upon epsilon naught epsilon r into A. This equation number 1. This is the resultant electric field between the plates. Okay. Now we know that potential difference between the plates V is equals to E into D. This equation we know that electric field between the 2 points which is placed at small d distance is equals to kq upon d square, and we know that v is equals to kq upon d. So from these equations we write v is equals to e upon d. So from this equation we can write e is equals to E is equals to V upon D. So from this equation, V is equals to E into D. Okay. Now put the value of E in this equation, then we get V is equals to Q upon A epsilon naught epsilon R into D. This is the potential difference between the plate of capacitor. Then capacitance of a capacitor C is equals to Q upon V. Put the value of V, then Q upon Q into D into A epsilon naught epsilon R. Q to Q cancel out, then we get C is equals to A epsilon naught epsilon R upon D. This is the capacitance of a capacitor when the dielectric constant completely filled in the between the plates of a capacitor. Okay. From this equation, we can write C is equals to epsilon R into C naught. Here, C naught is equals to epsilon naught A upon D. This is the capacitance when vacuum medium filled between the plates. We know that epsilon R always greater than 1. So, from this equation, we can say that when dielectric medium is filled between the plates, then the capacitance of a capacitor increases by epsilon R times. By epsilon R times the capacitance without a dielectric. Okay, so we can say that when we fill dielectric medium between these plates, then capacitance of that capacitor will be increased. Okay, students. Now, our next derivation, next condition, capacitance of a parallel plate capacitor if it is partially filled with a dielectric substance. Okay, now we take a small thickness layer of a dielectric medium between the plates. Okay, not a completely filled. In this derivation, we take a capacitor with A area of a plates, and this plate attached with plus Q charge, and this plate attached with grounded. Then due to induction, negative charge will be induced, and distance between these plates is T. Now we take a dielectric substance of dielectric constant epsilon R and thickness T. Thickness of this layer is T and dielectric constant is epsilon R. Then from this figure we see that the thickness of vacuum part, this is the vacuum. Thickness of a vacuum part between the plates will be vacuum thickness of vacuum part is equals to D minus T. D minus T. And electric field in vacuum is equals to E naught. It is represented by E naught is equals to sigma upon epsilon naught. And put the value of sigma is equals to Q upon A and epsilon naught. And induced the electric field in this dielectric medium, we know that induced electric field in dielectric medium, which is represented by EP, is equals to Q upon, from this equation, A epsilon naught epsilon R. It means 1 upon epsilon R times of a electric field in vacuum is equals to E naught upon epsilon R. So potential difference between the plates of capacitor is equal to the algebraic sum of a potential difference in vacuum and potential difference of a medium. So from this equation, V is equals to E into D. means potential difference in vacuum is equals to electric field in vacuum multiply thickness of vacuum plus potential difference in medium is equals to electric field in medium multiply thickness of a dielectric medium. So from this equation, resultant potential V is equals to V naught plus Vp is equals to V naught is equals to E naught into thickness of vacuum d minus t plus Vp. Electric potential in dielectric medium is equal to Vp. Vp is equals to electric field in dielectric medium and multiply thickness of a dielectric medium. Put the value of E naught and Ep, then we get V is equals to E naught Q upon A epsilon naught d minus t plus Ep Q upon A epsilon naught epsilon r into t. In this equation, we take common Q upon A epsilon naught, then d minus t plus t upon epsilon r. This equation number 1. This is the potential difference, resultant potential difference between the plates. Now capacitance of capacitor C is equals to Q upon V. Put the value of V, then Q upon Q into d minus t plus t upon epsilon r, multiply A epsilon naught. Q to Q cancel out, then we get C is equals to A epsilon naught upon d, and we take a common between these two factor minus t, then 1 minus 1 upon epsilon r. Okay, here we take a minus t common last two terms. In the last two terms, then we get C is equals to A epsilon naught upon d minus t multiply 1 minus 1 upon epsilon r. This is the capacitance when dielectric medium is partially filled in the capacitor. Okay. Now we take some cases. So case first, if T is equals to 0, that is dielectric medium is absent between the plates, then T is equals to 0, so this term will be 0. So C is equals to A epsilon naught upon D is equals to C naught. This is the capacitance of a capacitor when vacuum filled between the plates. And case second, if T is equals to D, it means dielectric substance is completely filled between these plates. Okay, in this case, C is equals to A epsilon naught epsilon r upon D is equals to this A epsilon naught upon D is equals to C naught. So C is equals to epsilon r into C naught. Okay, students, these are two types of effect of dielectric medium filled between the plates of a capacitor. Okay. Next type we will discuss about in the next video. Okay. Thank you.